Broadcast is now starting. All attendees are in listen-only mode.
Hello to all you out there in biomed land. Jack Barrett here, and my pleasure to bring you this afternoon's presentation, or morning or evening, depending as to your location, but do appreciate you all being with me here today. We are recording the presentation for future use, and at the end of the session, we will have time for questions and answers. So this is a seminar that I have given at several biomed symposiums, associations, and such. But in the interest of time, I have stripped out some of the theory of electrosurgery and some of the details on 60601 testing and such. Really going to focus in on the FT10 from Medtronic, Covidien, Valley Lab. And again, stripped out some of that information in the interest of time, so we'll have plenty of time for our question and answer. So again, today we will be focusing on the FT10. Let me just do a sound check here to be sure that this is all working correctly. And everything seems to be running well. So here's a snapshot of the FT10. And we have received permission from Medtronic legal department to utilize the image of the FT10. And quite a bit different, certainly than the force triad that many of you are probably familiar with. This is a much smaller, it's about 30% smaller in size and weight than the force triad, and clearly a big difference is one touch screen rather than the three that you saw on the force triad. There are two monopolar ports. Monopolar 2 is the port that would use the Valley Lab blended tool, and there is just but one ligature tool for use with this unit. You also notice that there is no red lights scanning down on the instruments. All of the surgical instruments used with this device have RFID tags in them that monitor the usage of the device. So I mentioned it is much smaller. It is also much faster. It's about 100 times faster internal bandwidth than the force triad, and to a surgeon, that will make a difference as far as impact on tissues. The rear of the unit, you have two monopolar foot switch inputs. And again, you'll see monopolar 1 is a 4-pin. Monopolar 2 is the 6-pin terminal. And that again would be used with the triverse pencil for the ligature. There is but one force triad. The ligature is just purple on this unit. The orange would be used with an adapter cord. And as I correct myself on monopolar 2, it is a Valley Lab triverse pencil that would be used on monopolar 2. Also on the back of the unit, you see a couple of additional ports. One for networking, which will become operational in the future, and a couple smoke evacuation ports. So the first test we'll talk about is the patient return monitoring. And we'll be using the Unitherm for all of our demonstrations today, which is the ESU analyzer manufactured by Rigel Medical. And typically, if you have been using a decade resistor box for doing your REM testing, the Unitherm will accomplish that for you. And the bottom display there is just a quick image of what the Unitherm display would look like. So compared to what you have done previously with the FX, the force triad, the REM test function on the FT10 is significantly different. It is auto-calibrating, so we're not looking for setting a resistance value of 120 ohms and increasing it, looking for that 135 ohm alarm, decreasing down to 5 ohms and looking for the alarm around 4 ohms, and also testing for the 40% increase in resistance and sounding alarm there. In the FT10, we simply dial in 4 different resistances. We'll test at 100 ohms. We will test at 50 ohms. We will test at 0 or short. And we'll also open up the connection to see what the open load resistance would be on the unit itself. So we'll be using videos for a number of our demonstrations today. To test the REM function, you use the REM cable with the clear plastic pin on the portion that goes into the unit. We're going to go into service mode and enter in the password 423213. RF output test. We're going to select pure for monopolar. We're going to pan up now to the display on the Unitherm. Notice that I have not connected both banana jacks to the REM output. The FT10 is going out and interrogated the resistance at about 70 Hertz. So we're going to set for 100 ohms. Back down to the generator itself, making the connection now. And now back down to the generator itself, where we're just going to quickly activate the RF generator so it goes out and looks at what the patient return monitoring resistance is. And you see that we measured on the display 103.6 ohms. Now we're going to set the Unitherm to 50 ohms. Toggle the generator. And we measure just under 54 ohms. Now I'm going to short the patient return cable. And we measure 1.7 ohms in the shorted condition. Here we're just really seeing the resistance of the cable itself. And now we're going to look at it open circuit. 1344 ohms. And all of those are within the acceptable tolerances. Now, one thing on that display we were just looking at, for those who are familiar with the force triad, that table was provided in the center screen of the force triads. So we're going to do some power output testing now. And for those who have gone to the Covidien school, typically you would use separate power resistors, low inductance power resistors, because impedance will always make a difference. We always talk about resistance as just DC resistance, but with a generator operating at 435 kilohertz, any inductance, any capacitance in your test circuit will impact the impedance that the generator sees, and that would also impact the readings that the analyzer will report. And if you have a lot of inductance, your power outputs, your currents will actually be higher than what they should be. So here we just have a quick display showing a cable coming from the active output of monopolar 2 through a separate current transformer to one end of the power resistor, and then a return back to the patient return. One thing to note here is there's unfortunately plenty of opportunity to become part of the circuit yourself, and that's something that you really would like to avoid. So with the Unitherm, I have in the bottom left-hand side a little schematic diagram that would be provided on the screen of the Unitherm that mimics what we just saw with the separate power resistor. So we come from the active electrode of the generator. Here I show a cable coming from monopolar 1. And one quick note on monopolar 1, that is also the UFB output. So if you're using shielded cables, be sure that the shield is pushed back as you insert the cable, the banana plug itself, into the output. Otherwise, the plastic shield may stay in place and inhibit you reading actual current and power being provided by the generator. We're going to go through a variable power load bank. On the Unitherm, this goes from 5 ohms up to 5,115 ohms in 5 ohm increments, and that power load bank is rated for a full 500 watts for a full continuous minute. Then we're going to go through a jumper to something called MD for measuring device. Actuality is that's our internal current transformer, and then back to the patient return. Now, when you look at the service manual for the FT10, it will suggest that you do all of your power testing in what they call the RF mode. And for those who still have a couple of triads around, which is now obsolete and replaced by the FT10, this would be what we used to call the debug mode. Now, we have gained permission from Covidien to use our foot switch adapters for the majority of the power testing on an FT10. And the other thing that I like to share with you is the basic process that we're going to use here today to look at power output testing on the FT10 generator is very similar to any generator that you would come across. The connections are all the same process. Typically what you'll see is just differences in what the load resistance is specified at. So as we hit the tool button, which is bottom right center of the FT10, this is the display that comes up, and here's where we can select a demo mode or service mode. I'm going to show you how to do testing in both modes so that we have that fully covered. One significant change that the service manual has allowed for with the FT10 is, as you remember, you used to do every output test on monopolar 1, every output test on monopolar 2, every output test on the UFP port. There is but one RF generator within the unit. There is some steering circuitry that delivers or determines what port the energy is delivered to. And as such, we only need to do now one test on monopolar 1, and that is a CoAG test where our load resistance is going to be set to 500 ohms. So we're testing at maximum power, 120 watts. We're doing spray. And if we watch, we will see the video of that happening. Now, the FT10 has 4 quadrants. Here I'm going into demo mode. And each quadrant is associated to the energy port that is next to. You'll notice that I have changed my page return cable now to one that does not have the red pin. And the quadrant becomes activated as I insert a pencil into the unit. Set the power to 120 watts. I have foot switch cables with a contact closure that the Unitherm will provide us that will energize the generator, and that saves us a little bit of time in the PM process. I'm going through now and setting up the screen for the CoAG test, setting my resistance to 500 ohms. Now I'm doing manual testing here. If I was doing this as part of an automated test sequence, which we have for the FT10 along with a number of other generators, all of the information here would be pre-populated for us. So here's the show diagram function that shows the active electrode coming out, going through that resistor that we just set for 500 ohms, and then back through the current transformer to the patient return. I'm going to hit the start button twice. As I do that, you'll see that quadrant on the display become active. So I had a test of 5 seconds on, 5 seconds off, and there you see the true RMS current that we measured, because again we have an internal current transformer. And with the Covidien products, you do PassFail based on the current reading. And there is the CoAG test on monopolar 1. So now we're going to go over to monopolar 2. We're going to do pure cut. Our load resistance is going to be set to 300 ohms, and I will show you how to do this test in both using the foot switch adapter, which turns on the generator for us, and I'll also show you how to use it in the RF mode. So first, with the foot switch adapter, notice there's a small micro switch on monopolar 2, and that switch has to be engaged before that portion, that quadrant of the display will become live. I'm setting it for 10 watts continuous. We're going to change our load resistance to the specified 300 ohms. And I'm selecting cut. My connection diagram. All of the data that you see here is the data that would be captured in the internal memory of the Unitherm when we're doing a test sequence in auto mode. And as you see that we were within the specification of acceptance for current. Now we're going to do the same test in RF mode. This requires a little bit more interaction between you, the biomed, and the unit itself. So again, we have to go into service mode, enter in the password 423213, RF output test, select our energy channel, our output port, and the power. I'm going to start the Unitherm. I'm going to hit activate. And there is my current of 181 milliamps that we gained through the use of our current transformer. And again, well within the range of acceptability. I'm not going to show Valley Lab mode. Valley Lab mode is a specialized waveform. It's a blended waveform of pure cut and a CoAG waveform. And that is their proprietary waveform. A lot of manufacturers have blended waveforms. Some folks will call it effect. And all it is a combination of cut and CoAG waveforms where the duty cycles of each are varied. I do show that in monopolar 2, on the small photo down in the bottom right, you see a triverse pencil connected to that output port. So next we're going to demonstrate doing a bipolar test. You'll see that I have 2 jacks now, or 2 leads coming out of the FT10 on the bipolar portion. We don't use patient return monitoring in bipolar. And there is the schematic diagram, bottom left, as to how we'll make our connections to the side of the Unitherm. So we're going to come from the active electrode through our resistor that we will adjust for 100 ohms, through our current transformer, and then back to the dissipative time on the generator itself. And then on the right-hand side is just a display, a photo caption of the test data that was captured. So for bipolar output, here are the tests that we need to perform: low, medium, high. So we're going to go now and do this demonstration. Notice again that there are 2 micro switches now. So when you're using your test leads, be sure that the leads are contacting those micro switches, otherwise the port will not be energized. I'm going to test at maximum power. I'm going to set it for bipolar, set my load resistance to 100 ohms. So we measured 959 milliamps, 92 watts is the power calculation. The FT10 has a tolerance on power as well, but again, the pass-fail is done on current. Notice the yellow LED coming on right above the yellow cables. That just indicates when my contact is closing on my cut output, and that is the cable going to the foot switch adapters that we put in place on the back end of the FT10. So there's the test that we just did, and again, everything is operating to our satisfaction. So next we're going to test ligature. Ligature is a form of a bipolar output. It is actually going out, as all of these tests really do, in a true procedure. The generator is acting in a closed loop mode, so it's monitoring the tissue resistance. And of course, tissue will increase in density as current starts to flow through it. And in ligature mode, we're using that to determine how much power to put into the vessel sealing device. Testing here is a little bit different than what you did on the Triad as well. There are 4 tests: bipolar resection, ligature at 5 watts, ligature at 350 watts. We're going to do the 350 watt test, and our range of current is 1940 to 2740 milliamps. Difference here with ligature is we're going to use 50 ohms as our test resistance. And I'm going to do this test in the RF mode. So I'm going down now, I'm selecting ligature as my mode. Unlike the Triad, you can hold the arrows up to quickly increase, decrease the power setting. So as I rotate the encoder, I have the ability to select different things, and as you can see, I started to select a different off time, which would not have done very well for us. But I got my act together, and I set the load resistance for 50 ohms. And again, what we're really setting here, we're setting a DC resistance. But what we'll see on the display of the FT10 itself is what the unit is seeing, what the generator is seeing for the actual impedance. And we measure 2.2 and a half amps. Now I'm going to zoom in on the screen. Notice there's a primary and secondary column on the left-hand side. The secondary is a current transformer that is closest to the actual output port of the FT10. And second from the bottom, you see the REM Z-mag, and you also, 4 columns up, see the impedance that the generator is seeing. Very important, because if there's a lot of inductance or capacitance in your test circuit, that number will be different and could lead you to an improper calibration of the generator. So just to recap what we did, we entered in the service password 42 3213. We have our connections on the FT10. We set the RF mode for ligature. We set the power setting, and we accomplished our test by pressing the activate button and then deactivate, manually turning the RF generator on and off. So next we're going to look at a couple of different tests. We're going to look at high frequency leakage and also cross-coupling tests. So if you ever visit a generator manufacturer, they'll all have this wooden table somewhere in their R&D lab. The specification for 60601 dealing with surgical generators -2-24 dictates very closely the layout of the wiring and how to do the measurements. Fortunately for biomed testing in our labs, we don't have to duplicate all of this. What we do need to do, though, is make sure our leads are relatively short as possible and that we don't have any coils, any inductance. We don't have our test cables laying across chassis and such, which could add capacitance that would impact our readings. High frequency leakage testing is always done single fault conditions. Just like when we do our electrical safety testing, we're doing single fault conditions. But here we're going to do single fault conditions where either the active or the dissipative patient return or dissipative bipolar leads are open. They simulate a failure in a connection somewhere of the circuit itself. And there is a limitation set by the standard as to how much leakage current can be allowed. And that standard says 150 milliamps through a 200 ohm load. A manufacturer can specify something smaller for a particular test, and you'll see folks doing that with bipolar testing or ligature testing, but they can never specify anything higher. The other thing to note when you're doing high frequency leakage testing is we're always setting the generator to maximum power. So we're changing our circuit diagrams here a little bit. And I think I said 601-2-24 earlier, which is the infusion pumps test standard. So -2 is the generator standard. I apologize. And on the Unitherm, we have two separate dedicated 200 ohm resistors that we use for our high frequency leakage testing. And one of them, of course, connected to earth ground, where our internal power load bank is not connected to earth ground. So here's the connections that we would make on the side of the generator. So this shows one of the tines from the generator coming into the Unitherm, going through our current transformer, and then a couple of jumpers connecting the 200 ohm resistor down to earth ground. Notice that there's also a scope output right above the measuring device, above the current transformer, so you can always hook an oscilloscope here to modify or monitor the current waveforms being generated if you chose to. So this would be an example of a monopolar test, open active electrode, monopolar cut, and we're setting the generator to 300 watts. This is a little snapshot of one of our auto test sequences where we've tried to include as much information from the service manual as possible so that you don't necessarily have to have a service manual in front of you as you're conducting your testing. Just trying to make it as simple and easy as possible. So again, there is our test circuit, and on the bottom photograph it shows what the test screens could look like. See that we provide the resistance value, 200 ohms, and the leakage current that we measured. And above on the test screen is where we can set in our leakage limit. Again, the default would be 150 milliamps, but if the manufacturer specified something differently for bipolar, 69 milliamps for instance, that could be set in that block right where it says leakage limit. And again, in an auto test sequence that we provide you free of charge, that would be preset for you for that particular generator type. So I'm going to show you two different tests here. We're going to do the active electrode first. So from the active electrode, there's your test screen that shows you what the limit was and what the actual measured value is. Now, in the data that we save internally, we would only show you the test results, not the limit, as that would be part of the test procedure. So that was the active electrode. Here we're doing the dissipative electrode. And note that it was a bit higher than the active electrode. Pretty common to see, quite frankly. The dissipative electrode quite often is higher than what you would see on the active electrode. Now, what I don't have, and I sometimes demonstrate in my live presentations, is I'll take the test cable, the lead from the pencil itself, and I'll roll it into a coil, and I'll press it on top of the chassis of the Unitherm itself. So I'm adding in some inductance and I'm adding in some capacitance. And typically I can make a generator give a much higher reading, especially on the dissipative, where it would fail. I can typically get that limit or the leakage current up to 250 milliamps. So the message here really is, if you're doing this test and you're getting a failure, especially if you're getting a close failure to the limit, just make sure that your leads are not coiled up anywhere, that there's no capacitance being added by running cables across a chassis anywhere. Just make sure they're nice and free and loose, as short as possible, and quite often you'll be able to get it to a passing state. And just as we did with everything else, bipolar, we would have to do high frequency leakage testing as well, active electrode by itself, dissipative electrode by itself. And here is the test sequence from their service manual, which talks about how to do the testing with doing it with Ligature. And notice that they set the limits here for 130 milliamps, which is just an example of what I was speaking of a bit earlier, where a manufacturer can choose to test to a lower current value for leakage current, but never a higher current value than 150 milliamps. So the next thing we're going to do is what's called cross-coupling. A number of different manufacturers will have you do this test. They may call it different things. The concept behind the test is, since we have monopolar outputs, we have bipolar outputs, we can have leads or in a procedure, surgical tools attached to monopolar 1, for instance, and also perhaps have bipolar tool attached to the patient somewhere as well, or perhaps leaning close to the patient. And what we want to ensure is that when we energize one of the energy ports, say monopolar 1, that we do not have excessive energy coming from any of the other output ports. So an example I was speaking of, if we energize monopolar 1 and there's another surgeon with a bipolar tool, we want to be sure that there is no energy being directed to those forceps. Kind of similar to our high frequency leakage testing, if you will. As far as the current limit, we're looking to have less than 150 milliamps. And the manual will have us go through, as will our test procedure, looking at output monopolar 2, looking at bipolar, looking at ligature while we energize monopolar 1. And then going over energizing monopolar 2 and looking at all the different outputs to be sure there is no current, no power being directed to that output port. I'm not going to stress you out by showing all those, but we do have one example. One thing I would like to share with you here is you saw that our display showed less than 1 watt, and that is an acceptable reading because what it's really saying is the steering circuitry inside the generator itself is working per design. You could see a little bit of current being output from time to time, but again, never more than 150 milliamps. So common question we always receive is, hey, I'm doing this test and I'm getting less than 10 milliamps, I'm getting less than 1 watt. Am I doing something wrong? And the answer is no, that is a typical reading when you're doing a test on the FT10. I spoke a couple of times of doing a test in the auto sequence mode, and I just wanted to share with you what the output of that test would look like. So important aspects here is we have the test date and time. Everything is associated to an asset ID, which is entered into the Unitherm at the very beginning of a test. It shows what test sequence was chosen. In this case, it's just a small little demo test that we have available for the generator and the analyzer. You see the instructions that we provide, and then you also see when you go down to 2/3 of the page down what the output results were. So this is a type of information that we provide for every test done in the auto sequence. Again, everything is associated to an asset number, time, date, all identified, so you have full data traceability and management of everything that is being done. And then this comes out as a CSV file, and then that could be used as an attachment to close out your work orders. So I'm going to open up here. I left 15 minutes for question and answer time, but just a couple of quick comments before we get there. We do have a guide on an introduction to electrosurgery that is available. You can obtain that by sending me an email or going to our website and requesting it there. I provide you with my cell phone information here, 860-729-9972, in case you'd like to give me a call at any point, any questions or whatever. I do want to put in a plug for Meta, which is a national organization of biomeds. certainly not in any type of competition for your local, regional, geographic associations, but one that is a bit more focused on the national level. And best news here of all, it offers free membership. So if you went to mymeta.org, you would be able to register for that. And since I'm on the membership committee of that organization, I would highly encourage you do so. Rigel is also an authorized distributor for IMT Medical. And that's it for the sale pitch here. I will open it up to your questions at this point. So we have one here that I can. Does output value would be changed if REM is min or max? It does do some self-calibration, but what we're really doing is checking to see whether it's within the limits specified. One thing to keep in mind when you're looking at those limits, you might remember when I shorted the cables together, we had about 1.7 ohms of resistance. So that impacts the readings that we're capturing when we're also doing the 50 ohm and 100 ohm test. If I'm reading this question correctly, measurement value should be milliamps instead of watts. So this does depend a little bit as to the manufacturer of the generator that you're utilizing. Many generator manufacturers do pass-fail based on power, and they will specify either plus or minus 15 watts or plus or minus 15 or plus or minus 20 watts are the two typical specifications. So if the generator is within that range, say you set it for 100 watts and the range is 80 to 120, based on a 20% tolerance, if it was within that range, that would be acceptable. Covidien, Valley Lab, Medtronic, Covidien products, Valley Lab products, all do their pass-fail based on current. So they'll give you a range of current that they want the output to be within. A couple of other manufacturers are starting to do that as well. I've seen some CONMED specifications on their latest generator that way. So it all depends as to the manufacturer and what they specify for you to do within the service manual, whether it is power-based or current-based. Within the Unitherm, we can do pass-fail based on either one of those. We have a power measurement that would be used if the specification is within power. And there's also continuous current if the specification gives you a bandwidth of RMS currents. Okay, will we have access to the videos you showed? Yes, I will have them published. It will be on our website. I don't have a time frame for you on that right now, but that certainly will become available. You're welcome, Alaska. So here's a good question. We just replaced our Force FX and Force FXC units. Are the monopole or bipolar pencils compatible with the FT10 units? As far as test pencils, yes. The Ligature with the RFID monitor chip in it now does have a one-time use. So if you're grabbing something from your surgical inventory and using that as a test pencil, that would be a limitation, but with Ligature we test via test leads anyway, so that should not be an issue for you. One other comment on this is the foot switch adapters that we provide for the FT10 are common to the FX for monopolar and bipolar, and to the Force Triad for monopolar, the 4-pin, and also the 6-pin is the same as is the bipolar 3-pin. And I think that is it for the questions that I have. If I'm missing something here, and I'm just quickly scanning through again, please do let me know. You can contact me by my email, which is on the screen, or give me a call on my cell. Here's a new one. How long does it take to do a PM? So with our test sequence, doing the full test, all of your high frequency leakage testing, all of your cross coupling testing, I've completed the PM test sequence in 45 minutes. Now, if you're doing it for the first time, it's going to take you a little bit longer because you're going to be double checking your connections. You're going to be double checking that you have your foot switch adapters in place and the cables going from the front of the Unitherm to the correct foot switch adapter, which is always a mistake I make. But once you're up and rolling in it, you should be able to get it done in 45 minutes. So unless there's something new that pops up here, we have completed our task. I truly do hope that you found this webinar useful. If you do have any further questions, again, please give me an email, please give me a call. I certainly appreciate your time. To those of you who have our Unitherms, very much appreciate your business. For those of you who have not gone down the Unitherm path yet, I hope you give us kind consideration when your needs increase. So thank you, everyone. Again, I do appreciate your time, and I'm going to shut down the presentation at this point.